Day 3, Problem 1. A 40-foot ramp has a horizontal length of 36 feet. Part A, sketch a diagram. Okay, so a ramp, kind of from the side, would look like a right triangle. It says it is a 40-foot ramp, so it's the diagonal side of the right triangle that is the 40 feet. And the horizontal length is 36 feet. That's this side here. So in this problem, the side of the right triangle that we do not know is this one here, the height of the triangle, or the height of the ramp. In Part B, use the Pythagorean theorem to find the ramp's height. So the Pythagorean theorem is a squared plus b squared equals c squared. The letter A is the shortest leg of a right triangle, and in this drawing, here are the legs of the right triangle, and the shortest leg is the side that we do not know, and so the variable A can be written on that side. Now the letter B is the other leg of the right triangle, and that is 36. And the letter C, the hypotenuse of a right triangle, that is the surface of the ramp itself, and that is the 40. Now to solve this equation for the letter A means we need to isolate the term that has the letter A in it. And to do that, we need to subtract the 36 squared. So subtract 36 squared, subtract 36 squared. The A squared comes straight down. 36 squared subtract 36 squared makes 0 and equals, and 40 squared subtract 36 squared. We need to figure out what that is. So on a piece of scrap paper, first of all, 40 squared. 0 times 0 is 0, and 0 times 4 is 0. Start the next row with 0. 4 times 0 is 0. 4 times 4 is 16. Adding together, 1,600. We want to subtract 36 squared. So how much is 36 squared? 36 times 36. 6 times 6 is 36. Carry the 3. 3 times 6 is 18, plus 3 is 21. Start the next row with 0. 3 times 6 is 18. Carry the 1. 3 times 3 is 9, plus 1 is 10. And add together. 6, 9, 2, 1. That's 1,296. Recall that we wanted to figure out 40 squared subtract 36 squared. And so that is 1,600 subtract 1,296. We can borrow from 60, leaving 59, and the 1 unit that we borrowed from 60 comes over with the 0 to create 10. 10 subtract 6 is 4. 9 subtract 9 is 0. 5 subtract 2 is 3. 1 subtract 1 is nothing. That's 304. To solve for A, we need to remove its exponent of 2 using square root. So the square root of A squared is equal to the square root of 304. The square root of A squared is A, and over here we need to figure out what the square root of 304 is. Now on scrap paper, let's see if we can come close with a guess. What is 17 squared? 17 times 17. 7 times 7 is 49. Carry the 4. 1 times 7 is 7, plus 4 is 11. Start the next row with 0. 1 times 7 is 7, and 1 times 1 is 1. Adding together. 17 squared is 289. That's Close, but still less than 304. What about 18 squared? So 18 times 18. 8 times 8 is 64, carry 6. 1 times 8 is 8, plus 6 is 14. Start the next row with 0. 1 times 8 is 8, and 1 times 1 is 1. And then adding together, this is 4. 4 plus 8 is 12, carry 1. 1, and 1 is 3, 324. We're trying to figure out the square root of 304. Well, 304 is in between 289 and 324. And so the square root of 304 is going to be more than 17 and less than 18. It's going to be 17 point and then some number that we guess in the tens position. Now, 304 is 20 units less than 324, and 304 is 15 units more than this. So it's not exactly halfway in the middle, but very close to halfway. I'm going to guess a decimal number of 0.4. And so the square root of 304, my guess is 17.4. In our drawing, the letter A is this side of the triangle, and it is the ramp's height. So we have figured out that the ramp's height is 17.4 feet. Now, day 3, problem 2. Graph figure A, B, C, D, and we are given the coordinates of point A, B, C, and D. So point A, 1, 1, that is here. Point B, 2, 3, here. Point C, 4, 3, here. And point D, 5, 1, is here. So this figure, when we connect these together, has 4 sides, and it happens to be called a trapezoid. Now, in question B, we're asked to graph the dilation of the figure using a scale factor of 2. A scale factor of 2 is going to create a larger figure that is the same shape as this, but all of the sides of that larger figure will be 2 times longer than these sides in this figure. Okay. So to find the new and larger figure, we're going to multiply these original ordered pairs by the scale factor of 2. And that will create a dot to be A prime, and it will create another dot, B prime. It will create C prime and D prime. So let's find these 4 ordered pairs. Starting with point A. Originally it's 1, 1. We are going to multiply those by 2. So 1, 1 multiplied by 2 would make 2, 2. On the grid, 2, 2 is over 2, up 2, right here. This is A prime. Okay. Now point B prime. Point B is 2, 3. Let's multiply each of those coordinates by the scale factor of 2. That will create 4, 6. So from the origin over 4 and then up to the 6, here is B prime. Now let's find C prime. Point C was 4, 3. Multiplying each of these by the scale factor of 2 creates 8, 6. And on the grid, over 8, up to the 6, here's the dot, C prime. And finally, D prime. Starting with 5, 1, multiplying these by the scale factor of 2, we get 10, 2. Over 10, up 2, here is D prime. And then we can connect those dots together to create our new trapezoid shape. Part B asked us to graph this. That is the shape in red, so that is done. And Part C asked for the coordinates of the dilated image. That is these ordered pairs. That part is done.